Okay, chapter 11 started with this system of two equations, and I picked a method to solve it. I used the substitution method. So right here I solved for A. I just subtracted C from both sides, and then I plugged that 250 minus C into the other equation, solved, and then plugged in here. I think most of us already remember that part. Then I wrote an augmented matrix, which just means that we put all the coefficients into a matrix. That line divides the equals bit. So this 1, 2, 3, -7 goes in the first row, and so on. An example of a matrix in upper echelon form is here. 1's on the diagonal and then 0's below. It really doesn't matter what's above. Step 1 here to solve this, the next step. So we always start right here in the top left, and from there we try to get a 1. So I divided the whole first row by 3, and this is what I got. And then we want to move right below. So once this is a 1, we want to move to the very next row and turn that into a 0. So I did this little row operation here to get a 0 in that spot. Third, now I have 1, 0, 0, 1, and what I need is a 0 here. So here's the row operation I did. Row 2 times -3 plus row 3, and that gave me this 0 here. And then what would I do next to solve this? I turned all of these into equations. So this x, y, z equals 5 is here, and then 1y plus 3z equals 6. 1x plus 3y plus 6z equals 12. So I started here and kind of cascaded backwards. So I put the z in. 3 times z is the 15, and solved for y. And now I put the z and y into this one so I can solve and get that third bit. This time I solved using Kramer's rule, which tells me that I write the augmented matrix, which is there, and then on the top I take the original matrix and I replace the x column with the 1 and the 5 because I'm being asked, because I'm first solving for x. So I replace this bit. On the bottom I put the original, and then I find the determinant, which you may remember is these two multiplied minus these two multiplied. So I got 10 minus -10. Same thing on the bottom, 30 minus -20. And that gives me 2/5. I do it again for the y, so this time I replace the y column with the 1, 5. Find the two determinants, and I get that y is 1/10. This one is a 3 by 3, which you don't have on the exam, but I'll kind of quickly go through it. So again, augmented matrix. I'm only asked to solve for x this time. So I replace the x column with the answers. On the bottom I put the original. And then here's where I calculated the determinant of that 3 by 3. So 10 times the determinant of this bit. -3 times the determinant of that bit. 1 times the determinant of this bit, and so on until I end up with this fraction. Again, you don't have a 3 by 3 in your exam, so not super important. The solution to this matrix is super easy because it just tells me 1x equals 4, 1y equals 2, 1z equals 6. This one doesn't have a solution because I end up with 0 x's, 0 y's, 0 z's equals 9, and 0 doesn't equal 9. So there's no solution. All right, here I did 3a. You literally just multiply 3 by each term. A plus c, you just add each bit in a to c. So 1 plus -2 is -1. 2 plus 0 is 2, and so on. The multiplication, remember, was a little bit trickier. So what we have to do a times b is I take this row, flip it up, and multiply it by this column. So 1 times -1 plus 2 times 0, which is where this comes from. And then I do it again, this row times this column, and so on until I've got all the bits. This one is b times a. Remember, it's a multiplication of matrices is not commutative, so I get a different answer because you see I rewrote b over here, and what I have to do is flip this row and multiply it by this column. So -1 times 1 plus 8 times 2 plus 5 times 3, and that answer goes here. For this one, I multiplied 2 times everything in a, and then I subtracted c, so I just do that piece by piece. 2 minus -2 is 4. 4 minus 4 is 0, and so on. And there's chapter 11 in a nutshell.